Hi students, this is Sivakumar, 11th standard mathematics, chapter number 1, continuation of exercise 1.2. Now problem number 7. On the set of all natural numbers, let R be the relation defined by A is related to B if A plus B is less than or equal to 6. Write down the relation by listing all the pairs. Check whether it is reflexive, symmetric, transitive, and an equivalence relation. You have to verify one by one. Before that, what you have tried? Listing all the pairs of the relation R. Okay. So here is the question. N refers set of all natural numbers. The relation R is defined by A is related to B if A plus B less than or equal to 6. This is a statement. First we can find R. Set of all natural numbers. Natural number starting number is 1. I start with 1. 1. I consider A that is equal to 1. What should be added with 1 to get less than 6 or equal to 6? Both can be considered. So I start with 1 comma 1. 1 comma 1, that if you add both 1 plus 1 that is equal to 2, 2 that is less than 6. I consider even B as 1. Then even you can write 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5. See, 1 plus 1 2, 2 less than 6, 1 plus 2 3, 3 less than 6, 1 plus 3 4, 4 less than 6, 1 plus 4 5, 5 less than 6, 1 plus 5 is 6, 6 is equal to 6, but what is given here? Less than or equal to. Even 6 can be considered. Total value 6 can be considered. Now I start with the 2. 2 comma 1, 2 comma 2, 2 comma 3 and 2 comma 4. We can go up to 2 comma 4 because 2 plus 1 that is equal to 3 less than 6, 4 less than 6, 5 less than 6, 2 plus 6, 6 is equal to 6. Now I start with the 3. 3 comma 1, 3 comma 2, 3 comma 3. That's all. 3 plus 1 is 4 less than 6, 3 plus 2 5 less than 6, 3 plus 3 is equal to 6. After that you can go for 4, 4 comma 1, 4 comma 2. 4 plus 1 5, 5 less than 6, 4 plus 2 that is 6, 6 is equal to 6. Then you can go for 5, 5 comma 1, 5 plus 1 is equal to 6. That's all. After that, no chance of taking 6 and all. If you take 6, you can go for 6 comma 1. The minimum of 6 comma 1, total value is 7. 7 is greater than 6. But what's the condition given? Less than or equal to 6. So you can stop at 5 comma 1. So we frame the relation. Now we had to verify whether it is a reflexive, symmetric, transitive and equivalence. We can verify one by one. First I start with a reflexive. Reflexive in natural numbers. In natural numbers we have taken number 1, we have taken number 2, we have taken 3, 4 and 5 also. Since we have taken all the 5 numbers 1, 2, 3, 4 and 5, 1 comma 1 must be there, yes. 2 comma 2 must be there, yes. 3 comma 3 must be there, yes. 4 comma 4 must be there, no 4 comma 4. 5 comma 5, no 5 comma 5. So how to write? Straight away we can write since 4 comma 4, 5 comma 5 both don't belong to that or refers a relation or is not reflexive. Okay. Next one, symmetric. For every a comma b belongs to R, b comma a must also belong to R. Generally we can say R is symmetric. We can verify one by one. Okay. For 1 comma 1, the reverse of 1 comma 1 is 1 comma 1 only. For 1 comma 2, the reverse of 1 comma 2 is 2 comma 1. That is also there. For 1 comma 3, reverse of 1 comma 3 is 3 comma 1. 1 comma 3, 3 comma 1. 1 comma 4 reverse is 4 comma 1. That is also there. 1 comma 5 reverse is 5 comma 1. Okay, then 2 comma 2 reverse 2 comma 2 only. 2 comma 3 reverse 3 comma 2 only. 2 comma 4 reverse 4 comma 2. And 3 comma 3 reverse 3 comma 3 only. Yes, for every a comma b belongs to R, b comma a also belongs to R. Therefore, R is symmetric. For every a comma b belongs to R, we have b comma a belongs to R. Therefore, R is symmetric. Okay, then we can go for transitive. Transitive, not for every a comma b, b comma c belong to R, b is common, a comma c belongs to R. Not for every. I give an example, you can understand. R is not transitive. Okay, give an example over here. I give two examples. I take 2 comma 2 and 2 comma 3. Why I am taking 2 comma 2 and 2 comma 3? Here ends with 2, here starts with 2, continuity is there. So the result will be 2 comma 3, that 2 comma 3 here itself. Therefore we can say that is transitive. In that case, I take 2 comma 2, 2 comma 3. Example, 2 comma 2, 2 comma 3 both belong to that R, which implies, since we have the continuity, you can write the result to 2 comma 3 that belongs to the set R. In that case, we can say R is transitive. And I give an example for not transitive. Suppose I take 5 comma 1, 5 comma 1 and 1 comma 5. I take 5 comma 1 and 1 comma 5. 5 comma 1, 1 comma 5 both belong to R. Continuity is there. Now what's the result? 5 comma 5. But 5 comma 5 doesn't belong to R. Look at that R. No 5 comma 5 at all. So in that case we can say R is not transitive, which implies R is not transitive. Already I told you, in any one case it is possible to prove not transitive means the final result is not transitive only. Okay. Subdivision 1, subdivision 2, subdivision 3, and finally subdivision 4. Even though R is symmetric, we have proved R is not reflexive and not transitive. The final result, R is not an equivalence relation. Even one case is failed, finally have tried R is not an equivalence relation. Though R is symmetric, R is not reflexive and not transitive. Therefore, OR is not an equivalence relation. So problem number 7 is completed. I'll be teaching that problem number 8 in the next video. Thank you, children.